Hello again, folks. And now let's talk about significant figures. We'll start by asking two questions. Question number one, how many empty pizza boxes are in this room with me right now? Question number two, how long is this pencil? For each of these questions, the answer is going to be a number, but they're not really the same kind of number. For instance, it should be possible for two people to count the number of empty pizza boxes in this room and have them come up with the same answer, assuming that they know how to count and that they're able to correctly see and identify what a pizza box is. The pizza boxes aren't hiding. If anything, the greasy, disgusting, empty pizza boxes are all too obvious. There are no fractional pizza boxes, so there are no decimal places to worry about. It's always a whole number of pizza boxes. The number of pizza boxes is a countable number, and there is no uncertainty in the answer. For the other question, how long is this pencil, we're counting the number of marks on the ruler, but the length of the pencil is not a countable number in the same way that the number of pizza boxes is a countable number. There are almost certainly going to be fractions or decimal places for the pencil, because the tip of the pencil is almost certainly going to be between two of the marks on the ruler. The number of pizza boxes is a countable number, the length of a pencil is a measurement, and there's no such thing as a perfect measurement. Well, you say, it might not be easy or worthwhile or practical to get a perfect measurement for the length of the pencil, but if I'm willing to put in the effort, nope. For example, how long is this pencil right here? Looks like 15 centimeters to me. I can't imagine why you would need to know the length of a pencil to a greater degree of accuracy than that in any sort of real-world example, but I'm only using the pencil here because pencils are easy to draw. Okay, it's definitely longer than 14 centimeters. It's definitely longer than 14.5 centimeters. I think 14.8 centimeters would be about here, so it's definitely longer than 14.8 centimeters. My best estimate is that this pencil is about 14.9 centimeters long. If I report the length of this pencil as 15 centimeters, I'm not using all the information that I can get from this ruler. My ruler is marked in centimeters, so I should be able to get the estimate of the length of the pencil to the nearest millimeter. I have three significant figures here. I'm absolutely certain the 1 is correct. I'm absolutely certain the 4 is correct. I'm confident that the 9 is correct. The significant figures are the digits that I am absolutely certain are correct, plus one more digit, the last digit, otherwise known as the least significant digit, which is my best estimate. If my ruler is marked to the nearest centimeter, then I can estimate to the nearest millimeter. If my ruler is marked in millimeters, then I can estimate to the nearest tenth of a millimeter. Whatever the markings are on my measuring device, I can almost always get one more significant digit by estimating where my measurement is between the two nearest marks on my measuring device. And I say almost always because, of course, there are going to be exceptions. Okay, this time I brought out a ruler that's marked in millimeters. The pencil is definitely a bit more than 14.9 centimeters long. 14.93? 14.94? My best estimate for the least significant digit is 14.94 centimeters. Now I have four significant figures. Okay, can we just keep going, using better and better quality rulers until we get a perfect measurement? Nope. Eventually you get to the point where you're trying to measure to the center of the nucleus of the last carbon atom at the tip of the pencil. Except that the last carbon atom is wiggling around in space because we're not at absolute zero temperature. Oh, and the tidal forces from the gravity from the Crab Nebula, they're a little bit different today than they were yesterday. Oh, and Heisenberg's uncertainty principle. It's theoretically and actually impossible to make a perfectly accurate measurement. Things that are countable have no uncertainty. There are absolutely 37 greasy, disgusting, empty pizza boxes with no uncertainty. Not 36, not 38. The answer is exactly 37. But things that have to be measured will always have uncertainty in the least significant digit. in real life, is 2 significant figures good enough for what I'm doing with this pencil? Then my pencil is 15 centimeters long. Do I need 3 significant figures? Okay, then it's 14.9 centimeters long. Do I need 4 significant figures? Fine, it's 14.94 centimeters long. Is there some reason that I might need more significant figures than that? Like 5 significant figures or 6 significant figures? Actually, you know what? Did you notice that at 4 significant figures, I say the pencil is 14.94 centimeters long, which is the same as 149.4 millimeters. But at 5 significant figures, I say it's 149.34 millimeters long, which is my best estimate using that ruler. If my rulers were perfect, and if my measurements were perfect, they should have agreed in that 4th significant figure, right? But they didn't, because there is always uncertainty in the last significant figure. No measuring device is absolutely perfect, and no measurement can be absolutely accurate. Okay, that's enough for now. Next time we'll talk about the rules for significant figures.